In the previous episode, Josh and Arabindo reviewed the growth of their beanstalk using their timeline. They found the factors by which the beanstalk grew over several time periods. For example, they explained that the beanstalk would grow by a factor of 9 over any 2-day period, because it grows by a factor of 3 over the first day, and then by a factor of 3 over the second day. In this episode, Josh and Arabindo will use their equation and timeline to find the height of the beanstalk on day 1/2.
What do you think the height of the beanstalk on day 1/2 will be? Draw a timeline and mark this in.
This is day 0. And just want to make it to day 1/2. We don't have to do anything else. And then, so this, we're starting at 1 centimeter, right?
Mm-hmm.
And remember we made like the equation like yesterday? So we were like saying that starting height times the growth rate, and the growth rate here is 3 times per day, right?
Mm-hmm.
And now we have half a day instead of put to the half on top. And that's basically the square root of 3.
Josh, are you familiar with the square root of 3? Does that have meaning for you? This symbol, does this mean something to you?
Yeah, it's like the number. That like, so the square root of 3 times the square root of 3 equals 3.
Okay, so you started to say it's the number. Can you finish that sentence?
It's the number you multiply by itself to get a number that's here.
That's under the square root?
To determine the height after 1/2 of a day, Josh and Arabindo used the formula they created in lesson 3, the starting height times 3 to the power of the day. Since they are trying to find the height on day 1/2, they plugged in 1/2 for x in their equation to get a height of 3 to the 1/2. They think that this is equivalent to the square root of 3. The square root of 3 is defined by Josh as the number that, when multiplied by itself, gives you the number underneath the square root sign. However, Jack is not convinced. In the next section, Josh and Arabindo explain why they think the height of the beanstalk is the square root of 3.
Jack isn't convinced. He thinks the beanstalk will have a height of 2 centimeters after half a day, because 2 is halfway between 1 and 3.
So Jack would be thinking like, so this is day 0, and this is day 2, let's say.
Okay.
In the middle would be day 1, and in the middle of that would be day 1/2, and in the middle of this would be day 1 and so we have day 0, and the starting height would be 1 centimeters. And we already knew earlier we had these filled out, okay? And so we wanted like find day 1/2 and day 1.5. But Jack thinks it's 2 centimeters, and in the middle of this it would be 6 centimeters. So does the times 3 rule still work for it? So from here to here the times 3 works, and from here to here the times 3 works, and from here to here the time. But from here to here the times 3 doesn't work.
From where to where?
From 6 centimeters to 9 centimeters.
Mm-hmm.
And we were saying that the times 3 works, but this is 1.5, so it's not supposed to work. So it's supposed to work from here to here,
Mm-hmm.
and from here to here,
Mm-hmm.
and also from here to here.
Mm-hmm.
And it does work.
Mm-hmm.
But we can also see that from here to here, it's times 2 in half of a day.
Mm-hmm.
So why isn't it from here to here another times 2? From 2 centimeters to 3 centimeters.
So what do you think, Josh? Do you think over those half-day increments it should have the same multiplicative relationship? Like, I think what Arabindo's saying is if it's times 2 over a half day, it should be times 2 over the next half day. Is that what you're saying?
Yep.
Do you think that that's right, or
Yeah.
you agree with that?
Yeah.
Arabindo noticed something important. He pointed out that if Jack was right and the height of the beanstalk was 2 centimeters on day 1/2, then the beanstalk's height would have increased by a factor of 2 from day 0 to day 1/2. This would mean that the beanstalk's height should increase by a factor of 2 from day 1/2 to day 1 as well. However, we know that this does not happen, since the beanstalk height is 3 centimeters on day 1. With this in mind, watch as Josh and Arabindo create a new timeline to explore what they believe to be the appropriate heights and growth factors.
On your timeline, does that work, Josh? Can you draw your timeline and see if that works?
Mm-hmm.
Do I just do it so it's multiplying by 2 every time?
Well, what do you think it should be at day 1/2?
Well, it should be the square root of whatever's, so it's just the square root of whatever's here on day 1.
Okay, and so at day 1 we know it's 3, right?
Okay. So do you want us to write it as an exponent or a square root?
Maybe both.
Okay, so here, you write it down. Yeah. Nice. And let's label the rest. So here we know that day 2 is 9 centimeters. And we think that it will be, it'll be 3 times the square root of 3. 3 to the 1.5.
Can you say again why it makes sense that it's 3 to the 1.5?
So with our rule, we saw that on day 0, 3 to the 0, the height is 3 to the 0, which is 1 centimeter.
Mm-hmm.
And then on day 2, if you test it, you got 3 to the 2, which is 9 centimeters.
Mm-hmm.
And it worked for day 1. So it makes sense that it should work for day 1.5, day 1.5 and day 1/2.
Mm-hmm. Can you write in those 3 to the first
Okay.
that you were talking about?
Or 3 to the 2nd centimeters. Or 3 to the 0 centimeters. Or 3 to the 1 centimeters.
Okay.
Centimeters.
Okay, this is looking really good. And this kind of looks like our equation from the last day, right? Or from yesterday. So can you tell me what, in our equation, what each of these numbers represented? Josh, do you remember in our equation what each of those numbers represent?
These.
Mm-hmm. So what does the 3 represent? What's the 1/2 represent?
The 3 represents every day it increases the height increases 3 times, and the 1/2 is because of day 1/2. So day 1.5 would be 3 to the 1.5.
Mm-hmm. And then the way we started this was we were thinking about Jack's timeline up here, and we were noticing that if it's 1 centimeter, 2 centimeter, and 3 centimeter, then this is a times 2 relationship, but this is not a times 2 relationship. What's happening down in our timeline? Are those multiplicative relationships the same or not?
So here we're doing times the square root of 3. And we're doing another times the square root of 3. And it's constant. And we keep on going and it's still working. But for Jack, it's a different scenario because he is multiplying between days, but he's adding between the half days.
So there's kind of this inconsistency where over the full days it's multiplication, but over the half days it's addition.
Yep.
In this episode, Josh and Arabindo determined the height of their beanstalk on day 1/2. Using the equation they created in lesson 3, they found the height was 3 to the 1/2 centimeters. They then argued that this was equal to the square root of 3, using their timeline. They suggested that the height of the beanstalk should increase by the same factor over each half day. This idea is consistent with the other relationships they have found. For example, They know that over each 1-day period of time, the height increased by a factor of 3. Over each 2-day period of time, the height increased by a factor of 9. And over each 5-day period of time, the height increased by a factor of 243. If Jack's conjecture that the height on day 1/2 was 2 centimeters was true, then the beanstalk's height would not have increased by the same factor over each 1/2 day. Thus, Josh and Arabindo determined that the height should be the square root of 3. This way, the height increases by the same factor over each half-day period. In particular, from day 0 to day 1/2, the height increases by a factor of the square root of 3, and from day 1/2 to day 1, the height also increases by a factor of the square root of 3. This means they know the height of the beanstalk on day 1/2 can be expressed both as 3 to the 1/2 and the square root of 3. This means 3 to the 1/2 equals the square root of 3. In the next episode, the students will find the height of the beanstalk on day 1/4.